Given the two functions, f of x equals the square root of x and g of x equals x squared minus 25, we want to evaluate each of these expressions. Now, before we get into solving the problem, let's just talk about how functions work. What are our functions? So you could think of a function as an input-output machine. You input a number, the function does something to it, and then you output another number. So let's just look at the f of x function, the f function. F is the name of the function, and x is the input variable. So we could visualize a function like this, where we have some set of input values, we'll denote those as x's, and some set of output values, we'll denote those as y's. And so the function takes a number, let's say, I'll pick one that's convenient, let's say the number 16. So the number 16 goes into the function, and the function is the square root function. So it takes an input, takes the square root of the input, and then yields an output. So the square root of the input, the square root of 16, is 4. And so that gives us the ordered pair 16, 4. Now what we're doing in this problem is taking this one step further and looking at a sequence of two functions. So we have an f and a g, and it's important to sort of keep in mind which one comes first and which one comes second. All right, so we can sort of look at it, let me make it a little bit smaller. We have the x's as the input to the f function, and then we have our outputs, and those are the y's. But let me call those the f of x's. So the function value. So you could say f of x or y. Since we have two functions, and the f function has y values and the g function has y values, I don't want to just use y, I want to be more specific and call the y values for the f function, f of x, and the y values for the g function, g of x. Now if we then apply a second step, so the outputs of the f function, or the first function, will now be the inputs of the second function. And so if a number goes into the f, a different number comes out, and then that number goes into the g function. And then another number comes out. And so the number that comes out is whatever the g function does to the value f of x. So that will be g of f of x. Or if the g function comes first, we have x's here, the x value goes into the g function, and then the g function spits out some output value, we'll call that g of x, and now that output of the g function, the g of x, that goes into the f function. And then there's an output of that function. So two things happen to the number, the original number. Either it goes into the f and then the g, or it goes into the g and then the f. So if it goes into the g function first, out comes g of x, and then that g of x goes into the f function, the output will be f of g of x. All right, so let's look at number 1, for example. F of g of 5. Now you always want to work inside out. So first, the g function is applied to the number 5. So the number 5 goes in. Now the g function takes that input and first squares the input, that's x squared, and then subtracts 25. So the g function is x squared minus 25. So the 5 goes in, it's squared, you get 25, and then subtract 25 from that, you get 0. So g of 5 would be 0, and now that 0 goes into the f function. And the f function is the square root function. So it takes the square root of the input. 0 goes into the f. You take the square root of 0. Out comes 0. So f of g of 5 should be 0. Now if we go in the other direction, g of f of 5. So here we start with, now let's switch to a different color. We start with f of 5 first. So the number 5 goes in. The f function squares it. Or sorry, the f function takes the square root. So out comes the square root of 5. And now the square root of 5 goes into the g function. And the g function says take the input, square it, and subtract 25. So if we square the square root of 5, we get 5. And then subtract 25 from that, we should get negative 20. Should be a negative sign there. Equals negative 20. Now, sometimes, coincidentally, f of g of x or g of f of x both give you the same value, but normally they don't. In this case, you get a 0 if the g function comes first, and you get a negative 20 if the f function comes first. And we could do the same thing with the number 0 and the number negative 6 for part C and part D. So in for part C, g of f of 0 means we plug 0 into the f function, which would be the square root of 0 or 0. And then, once we have that 0, the second step is we plug 0 into the g function. So we take 0 squared minus 25. So we'll have negative 25. And for part D, f of g of negative 6. So we plug negative 6 into the g function. So g of negative 6 would be negative 6 squared minus 25. So negative 6 squared is 36. And 36 minus 25 is 11. So for the first part, the g function, we get 11. And then we plug in 11 into the f function. We should get the square root of 11. All right, so for part A, B, C, and D, we're using a specific number. And that number has two functions applied to it. Either the g first, and then the f, or the f first, and then the g. All right. And so now for part E and F, rather than using specific values for the input, we're using the functions themselves. So for part, let's do down here, for part E, f of g of x. Well, the g of x is x squared minus 25. So we could replace that g of x with x squared minus 25. So now this is saying we take x squared minus 25 and plug that in to the f function. And the f function takes the square root of the input being x squared minus 25. So we get the square root of x squared minus 25. And if we did that in the reverse order for part F, that means the g function is on the outside and the f function is on the inside. So we replace f of x with what f of x is defined as, the square root of x. That's g of the square root of x, meaning we plug the square root of x into the g function. And the g function takes the input, squares it, and then subtracts 25. So our input is the square root of x. We square that, we get x, and then we subtract 25 from that. All right, so that about does it. Now, with functions, in this case, in these 6 problems, it's the composition of, with 6 examples. Each one is the composition of 2 functions, f and g. So either f of g or g of f. Now, you could string functions in any number. You could have f of g of h. You could have 10 functions, one after another. And what's important is you always work inside out. And just one more thing I want to say. Another way you may see this written, let me just scroll down here. So when you see f of g of x, another way you may see this written is f with a little circle, meaning of f of g of x. These are 2 ways of writing the exact same thing. So in this problem, we see it written like this. In another problem, you just as likely may see it written like this. I think that on the left is a little bit more visually apparent what's going on, but either way, they're both common notations. All right, that does it for this problem. I hope this was helpful.